Hi all, very good morning. Welcome to the 4-1 semesters. Myself is V. Dhananjay Naidu, working as assistant professor in AAA department. In current semester, I am going to dealing about the subject is special electrical machines. So, what is meant by special electrical machines? Special electrical machines is constructionally and technically and functionally it is little bit different from the conventional machines. The conventional machines means induction motor, synchronous motor, DC motors. These are all called as the conventional machines. Special electrical machines means stepper motors, digital reluctance motors, brushless DC motors, linear induction motors, AC servo motors, hysteresis motors. All these are called as the special electrical machines. So why we are calling as special electrical machines means these are the machines we are used only for the special purpose applications. Means like where we required a small power rating applications, where we required a low speed applications, there only we are going to using these machines. But in case of conventional machines, these machines are a bulk energy conversion machines. Means where we required a large power and where we required where we required high speed applications, there only we are using the conventional machines. So let's say for example synchronous motors and induction motors. So these are high speed motors. Okay. And again in the special electrical machines, whatever the supply we are giving to the stator windings, three-phase stator windings, this supply is not applied to all the three windings at the same time. Only the supply applied only few of the phase windings at a time. That means if there are three windings in the stator windings, then at one particular time we are going to energize only one or two phases, but not all the three phases are energizing at the same time. But in case of the conventional machines, if you are considering the three-phase induction motor, there we are applying the AC supply to the three-phase windings of the stator at the same time. So all the three windings, phase A, phase B, phase C, all the three windings are energized at the same time for a particular time. But in case of special electrical machines, only few stator windings are energized at a particular time, but all the windings will not be energized at that particular time. Okay, are you getting me? Are you understand? Okay, that is the difference of energizing of these special electrical machines and the conventional electrical machines. Okay, so I will discuss more depth about these special electrical machines after explaining the outcome based education. So now we will look into the outcome based education. Before that outcome based education, what is meant by output based education? Before 2000, our education systems are following the output based education system. So output based education system means at the end of the course, how many of the students are passed out from the course, or how many of the students are achieve the better percentage, like 70 to 80%. So the institutions are focusing on only on these activities. So that is the output based output based education system. They are not bothering about the how many of the students are uh, getting an opportunity at the end of the course, but they are bothering about the number of students has to be passed from the course, or the number how many of the students are achieved the better percentage when they are pass out. They are expecting only those things only. But in case of the outcome based education, this is not this is not like that. So outcome based education is a student centric teaching and learning methodology in which the course delivery and assessments are planned to achieve the stated objectives and outcomes. And also in this outcome based education, on how majorly focusing on measuring the student performance. That is very important in the outcome based education. Measuring the student performance at every level. At every level means, for example, if you are studying the first year, first semester. So in that first year, first semester, we are assessing the our we are assessing the students means by conducting the first mid one, mid two exams, and by conducting the final exams. So every semester, every level, we are going to measuring the student performance. So that is called as the students' outcomes at different levels. So this is the outcome-based education. The main motto of the outcome-based education is at the end of the program, the student should go out with a opportunity. So with the opportunity means at the end of the fourth year, the student should be placed in any company like software or core company. Or the student should be a self-employment. Means once he has completed the graduation, he should be in a position to uh, form a business or creating a company. So that is called as a self employment. Or the student should be grab a seat in higher education. Like in our department, we are conducting the GATE classes for to get a seat in the MTech means to get a seat in IITs or NITs. So we are conducting the GATE classes for the GATE. So in that way, if he crack the good rank, crack the GATE, if he get the good rank, then obviously he will be get a seat in IIT or NIT. So he will be pursuing the higher education. So at the end of the program, the student should be go with a some opportunity. Either the student should be placed in a company software or a core company, or either it should be a self-employment, or it should pursue a higher education. So that is the main objective of the outcome-based education. So to achieve these things, the outcome-based education again classified into or defined into four levels. One is the program education objective, first one, and second one is the program outcomes, and third one is the program specific outcomes, and fourth one course outcomes. So by using all these four outcomes, we are measuring the outcome based education. Okay, first one is program educational objects. Actually, these are the broader statements. We are our department or institution will define these statements. So here, what is that means? Program education objective means it describes the career and the professional accomplishments in your 4 years degree. In your 4 years degree, first the institution will define your career and professional accomplishment in what you have to complete the during the your program. So that is what after graduation that the program is preparing graduates to achieve. Whatever we have been defined, you should achieve those things during the graduation. During the graduation, that is called as a programmable educational objectives. Next one is the program outcomes. These are the statements that describe the what the student should have the knowledge during the program, and what the students should develop the skills during the program, and what the attitude behavior and attitude so students should develop the at the time of the graduation. That is the very important. So that is called as the program outcomes. So already you know that there are 12 POs, PO1, PO2, and like that there are 12 POs. So already you are all aware about these 12 POs. No need to discuss again on once again. So already you have these 12 POs and program specific outcomes in your classrooms. So just go through it and you just understand it. So already we have been discussed many times about the program outcomes and program specific outcomes. So we are not going to again explaining about these things. No need to waste the time. So I'm going to the next program specific outcomes. So these program specific outcomes are specific to a program. These are specific to a program. See, in our college there are 4 branches. Okay, so not 4, 5 branches. So every branch having the unique specific program outcomes. So these program specific outcomes are defined 2 to 4 program specific outcomes. In our department, we have been described the 2 program specific outcomes. So already you are very well about these program specific outcomes. Okay. Next one is the course outcomes. Course outcomes are what the students are required to attain at the end of the course. at the end of the course. What the students are required to attain at the end of the course. So generally course outcomes means what the student able to do or able to perform at the end of the course is called the course outcome. So these course outcomes should be observable and measurable. They should be observable and measurable. And also course outcome addresses a subset of PSOs and POs. PSOs and POs. So this is no need to discuss about this one. Leave it. So these are the four different levels of the outcomes: programmable educational objectives, program outcomes, program specific outcomes, course outcomes. By using these four levels of outcomes, we can measure the object outcome based education. Okay. Next one is the what is meant by course objective. Course objective is what the student will able to learn the course is called the course objective, or what the teacher able to teach the course to the student is called the course objective. So for our subject special electrical machines, we have written here 5 course objectives. We can write any number of course objectives, but they should be at least 3 course objectives for every subject. So these may be varying based on the syllabus. The course objectives may be varying. So we can write it 3 or 4 or 5 or 6. So it is depending on the syllabus. Based on the syllabus, we can write the course objectives. There is no fixed number of the course objective for every subject. It can be variable because it is depending on the course syllabus of the course, framing of this course. Okay, so here there are 5 course objectives. The first course objective to learn the operation and characteristics of the permanent magnet DC motors. So first we will see the syllabus of the unit 1. So the syllabus is unit 1 is permanent magnet materials and permanent magnet DC motors. So in this unit, the students will learn about the different classification of the permanent magnet materials which we are used in the electrical machines. And also the student will learn about the minor hysteresis loop and the recoil line, and also development of electronically commutated DC motor from the conventional DC motor. Okay. So electronically commutated DC motor means here the commutation is different compared to the DC motor. So in the DC motor, there is the commutation takes place in the rotor, but in case of the permanent magnet DC motor, the commutation takes place in the stator. So, and also here, these commutation is electronically commutated commutation process. So why? Because all the stator windings, the currents are commutated every phase for every time. So means, for example, ABC stator windings are there. Okay. So if A stator winding is energized and BC are commutated, current commutated means there will be no current flowing through the B and C windings. Only the current will be flowing in the A phase winding, means commutating the B and C. Current is commutated in the B and C. So there is no current is flowing through the B and C. After some time, means after 10 milliseconds, A phase may be commutated and B phase will be energized. That means the current will be flowing to the B phase. So that is means the electronically commutated. So here we are going to learn about the development of electronically commutated DC motor from the conventional DC motor, and there are how to the characteristics of the BH loop and demagnetizing characteristics, magnetizing characteristics and demagnetizing characteristics. We are going to learning about this one. So from the first unit, we are going to learning about the different types of the materials which we are used in the class electrical machines, and also you are going to learning about the operation and construction of the permanent magnet DC motor, and also you are going to learning about the how to develop the electronically commutated DC motor from the conventional DC motor. So these are all the objectives of the unit 1. So the all the objectives will be we are going to, so there are 3-4 objectives I have been discussed in the unit 1. The 3-4 objectives can be combined to define as a one objective. So that is the only one objective from the unit 1, that is to learn the operation of the permanent magnet AC motors and also the characteristics of the permanent magnet and also the performance of the permanent magnet AC motor. So all these things will be learned at the for the unit 1. Next one is the unit 2. Unit 2 is the stepper motors. So again here in this unit, the stepper motors are divided into two parts: variable reluctance stepper motor, hybrid stepper motors. So here for each part we are going to discussing about the, or you are going to learning about the construction and principle of the stepper motors, and also different configuration for the switching the phase winding controls, and also you are going to learning the open loop and closed loop control of two-phase hybrid stepping motor, and at the same time you are studying about the three-phase variable stepper motor, open loop and closed loop. So these are the things you are going to learn for the unit 2. So for this one, the course objective is we are defined as the student will able to learn to study the operation performance of the stepper motor and also different control techniques of the stepper motors. This is the course objective for the unit 2. Next, unit 3, going to the unit 3, switched reluctance motor. Unit 3 is the switched reluctance motor. So here also again you are going to study about the construction, different types of the constructions, and also you are going to studying about the operation of the switched reluctance motors, and we are comparing the conventional switched reluctance motor, conventional switched reluctance motor, and not conventional switched reluctance motor and conventional motors. And also mainly we are concentrate in this unit is the design of the stator and rotor polars. Why? Because by properly designing the stator and rotor polars, so you will get a higher efficiency for the switched reluctance motor. And also the next one is the most important is the different converter configurations for the switched reluctance motors. So here there are different types of the power circuits we are used to operate the stator windings. There are different power converter circuits. Power circuits. There are 3 to 4 power converter circuits are used to operate the stator windings of the switched reluctance motor. Okay, next one is the drive and power circuits of the switched reluctance motor. And next you are going to learning about the position sensing of the rotor and applications of the switched reluctance motor. Okay, I will explain you the application and everything at the in the next class. Just for how we are writing the course object for each unit, I'm going to discuss that only. So for this unit 3, the course objective is to understand the student will able to understand the student will learn about learn the operation, design and control of switched reluctance motors. What is the course objective for unit 3? To understand the operation, design and control of the switched reluctance motor. That is the course objective for the unit 3. And next, unit 4 and unit 5 we have written a combined course objective. Why? Because these construction and operation are more or less same. That's why I have written only one course objective for the both the units, unit 4 and unit 5. Square wave permanent magnet brushless DC motor. So here also we are studying the different types of the uh, construction of the brushless DC motors, and also here we are discussing about the principal operation of the brushless DC motor and deriving the torque and EMF equations for the square wave brushless DC motor, and also we are deriving the efficiency of the square wave brushless DC motor, and we are also finally discussing about the 120 degrees and 180 degrees magnetic area computation for this square wave brushless DC motor. This is the unit 4. The next one is unit 5 is the sine wave permanent magnet brushless DC motor. Here also you are going to learning about how to write down the torque equation and how to write down the EMF equation for a particular sine wave permanent magnet motor, and how to draw the phasor diagram and the circle diagram. And also the student will also learn about the torque speed kinetics. So how the torque is varying by varying the speed. So they can also learn about the torque speed kinetics. And finally, the main objective of this unit is compare the comparison between the square wave and sine wave permanent magnet motors. And finally, applications are same for the square wave and the sine wave permanent magnets. So here the objective of the 4 and 5 course objective for the 4 and 5 units is To understand the operation and characteristics of the square wave and sine wave permanent magnet brushless DC motor. This is the course objective for both the machines, for both the motors. What we are learning operation, characteristics of the different characteristics of the square wave and the sine wave permanent magnets brushless DC motor. And last unit is the linear induction motors. So linear induction motor means, so the rotor is moving in a linear way, means the motion is a linear motion. In case of conventional motors, the rotor is rotating nature. The motion of the rotor is rotating nature, but here the nature of the rotor is the rotor is, it is moving linearly, means it is moving a straightforward way. So that's why we are called as the linear induction motors. So the construction and everything is same as the induction motor. Okay, so here we are going to studied about the principal operation and what are the different types of the linear induction motor. That is the one-sided linear induction, two-sided linear induction motor. And also we are studying about the schematics of the linear induction motor drive for the traction. How we are utilizing each linear induction motor in the traction systems. That is what we are going to studying, and also the equivalent circuit of the linear induction motor. So that the course objective for this subject is to study the construction and operation and application of the linear induction motors. So that is the course objective for the unit 6. So we have seen the different we have seen the course objective, or we have defined the course objective for each and every unit. Okay, so there are 5 course objectives. Now once the course is over, so now the student able to perform or able to obtain these knowledge once the course is completed. So the course outcome for this subject is the student able to do or perform at the end of the program or course is called the course outcome. Course outcome is what the students should be able to do or perform at the end of the program or course is called the course outcome. So here we have defined the 6 course outcomes for this subject. Okay, the first course outcome is the student able to obtain the knowledge about the construction of the permanent magnet DC motor, operation of the permanent magnet DC motor, and also characteristics of the permanent magnet DC motor. The second course outcome is the student able to understand the operation of the stepper motor, different types of the stepper motors, and also performance of the stepper motors, and also understand the different control techniques of the stepper motor. So that is the course outcome for the unit 2. The next course outcome for 3, the student able to understand the operation of the switched reluctance motor. Okay, again the switched reluctance motor, there are 2 different types of the switched reluctance motor. So they are understand the operation of the different types of the switched reluctance motors and design. So already told you that design the stator polar design, rotor polar design. By properly designing that, so we will get the F6 is higher for the motor. So he also able to design the stator polar rotor polar of the switched reluctance motor, and also he should able to control the switched reluctance motor. He should be able to control the switched reluctance motor. The next one is the course outcome for the student able to describe the operation. He should be in a position to explain the operation of the brushless DC motor, square wave brushless DC motor, and as well as you should be able to explain the logic scheme of the square wave brushless DC motor. The next one is the course outcome 5. He should be able to understand the operation and logic scheme of the sine wave brushless DC motor. That is a course outcome 5. The next one is the course outcome 6. You should be able to explain the construction of the linear induction motor, and also you should be able to explain the operation of the linear induction motor, and also you should know what are the different applications of the linear induction motors. So these are the course outcomes of the special electrical machine subject. So there are 6 course outcomes. We have been discussed for the, we have been defined for the special electrical machine subject. So I think right, I think you are very well. You are knowing about the course outcome. What is course outcome and what is course objective? So course objective means what the student will able to learn about the course is called the course objective, and course outcome means what the student able to do or perform at the end of the program or course is called the course outcome. And now you are well known about the what is outcome based education. So to achieve that outcome based education, what the uh, students should be perform, or what the students should be able to do the things, so that he will get in a good opportunity when the course is completed. Okay, these are the different. This is the outcome based education. So if you have any doubts, you can ask me, or you can, if you can call me, or you can ask me in the next class. Okay, now the time is over. So okay, thank you to all of you for listening my class. Thank you.